Hyperbola. It is a set of all points x and y in the plane such that the absolute value of the difference of the distance from x comma y to two fixed points called the foci is constant. Also down here, guys, this is great to have. If you notice down here some formulas, these are great to know and to have available. So I would encourage you to take it and put it on a flashcard or put it on your formula sheet while you're working on this section. All right, let's solve it. It says find the distance between the 2 points and the midpoint. So above here, as y'all can see, is the formula for distance and midpoint. Just trying to scroll up to show you. There you go. All right, and some of you may remember it from the college algebra. Let's find our distance first. Well, before we do that, I want to just do a refresher. We know that it's x comma y. We know that, right? The order pair is. Let's call this order pair 1. So that means I got x subscript 1 comma y subscript 1. Let's call this one order pair 2. So it's x subscript 2, y subscript 2. Now, knowing that, when I solve for my distance formula, I know I got x from order pair 2 minus x from order pair 1 squared plus y from order pair 2 minus y from order pair 1 squared. Now let's solve. My x, hang on, I'm going to give myself some. Let me change this right quick so you can see my changes. Oh. All right, well, we'll just stick with orange. So my x from order pair 2 is a negative 4.4. My x from order pair 1 is a 2.6. My y from order pair 2 is a negative 1.3. Let me clean that up. Well, never mind. Let's just leave it alone. My y from order pair 1 is a 3.7. I am going to clean it up just because it looks like a mess. Negative 4.4 minus 2.6 squared plus negative 1.3 minus 3.7 squared. All right, so you could do it all in one setting in your calculator, or if you want to do it piece at a time, that's good too. Let's do that. I got negative 7 squared plus negative 5 squared. So now that's going to be 49 plus 25. So 49 plus 25 gives me 74. And this doesn't factor down. So that's my distance, square root of 74. If it's asking for the exact value, leave it in the square root form. That's what you want to get. If it asks us for decimal form, then round it. All right. Midpoint. We are going to take x from order pair 1, add it to x from order pair 2, divided by 2, comma. Y from order pair 1 plus y from order pair 2 divided by 2. Let's plug it in. Now, my x is 2.6 plus the negative 4.4, comma. Y is 3.7 plus a negative 1.3. Okay. So what do we got? 2.6 minus that 4.4 divided by 2. I get negative 9/10. 3.7 minus 1.3 divided by 2. I get 6/5. And that's my midpoint. All right, let's go to our next example. My screen's not wanting to move or cooperate, sorry. There we go. Now, example 2 says the graph here given of the hyperbola with the foci, the vertex, the isotopes, the points on the y-axis, so are 0, 3 and 0, -3. So the points on the x-axis to the left and right are given to us here as well as negative square root of 34, 0, -5, 0, 5, 0, and positive square root of 34, 0. So all these are given to us. So we want to identify the vertices of the hyperbola. So the vertice of the line that transverses axis, which is in this case, is horizontal. Okay. Which makes sense because if you'll see, the red here is my hyperbola, right? And they are like this, right? So our axis is going to be horizontal. All right. So the coordinates of the left vertex of this hyperbola is going to be, in this case here, the -5. My eraser is going to work. So we're just looking at the graph and reading it, right? That's all we're doing right now. The other vertex of this point is going to be this other side. So I am looking at, let me change this, these 2 points here. If we look at them, right here, whoops. And then we have the foci points, which is right here behind it. It's not on the line. Remember, that doesn't change just because we're working with a hyperbola. All right, so the foci also lies on that transverse axis. So here is and then we're recognizing those points because it's it's the transverse axis because we are focused that way. Remember when I was doing the parabola, we called them axis of symmetry, that our parabola opened up or downward, so it was X. If it opened side to side, then it was the Y value. In this case here, you can see. So if it opened side to side, it was a horizontal, which was the Y value. In this case here, it's the horizontal. But they're making the statement at the point of X here. Okay, so I didn't want you to be confused. My pen will go back to work, and here in a minute we'll write. If A is the length of the transverse axis, and B is half of the length of the conjugate axis, the distance of each focus from the center of the hyperbola can be calculated as followed, as C equals the square root of A squared plus B squared. Okay, so knowing this, we can acknowledge what is A, what is B, and then solve for C, or we can know what C is. Okay, so sometimes it's given, but in this case here, let's plug in what we know. Well, my A here is my 5, and my B is my 3. So now I got 5 squared plus 3 squared, which is 25 plus 9. That gives me 34 squared. We can see if something factors out. I'm just going to say it doesn't, stays that way. Yeah. Okay, so now that I've known that, what did that give me? That gave me my foci right here. So, right, gave us that. So we know we get a plus or minus. Here we go. All right, if we find the slope of the isotope, we're going to use m equals y from order pair 2 minus y from order pair 1, all divided by x from order pair 2 minus x from order pair 1. So y from order pair 1 and 2 So what I get, we have 3 minus 0. Ooh, my apologies. I read it backwards. We're going to call this 1, call this 2, right? Or you could flip the order. Just be careful how we write this. It could have been this, could have been this, depending on which order we chose. All divided by, I'm going to go ahead and stick with this order that I went with, but these are the 2 order pairs we're working with. Now for the x value, so now I have 3/5. So I have the slope of 3/5. Now I can write my my slope intercept form. It's y is equal to 3/5 x. I can find my x-axis or my x and y intercepts, which is already given to us. It's right here at the origin. Right, it's already plotted, but if I plugged in 0 here, I get 0 there. So we know that. So my answer, because we're looking at the slope, we're looking at these blue dotted lines, right? We know that we're going to have a plus or minus 3/5 x. And this is answering what it asked us to do. Okay. Moving on. Now we're going to determine the foci and the equations of the isotope, and we're going to sketch the graph of the hyperbola, which was already, the graphs are here. We're going to pick which ones, right? So first, I want to determine what is C in order to determine the foci. So I'm going to say, okay, I got C squared is equal to A squared plus B squared, and we know what A squared is. It's 16. We know what B squared is, 9. That gives me 25. C squared, square root, plus or minus. C is equal to plus or minus 5. So I know that I have a foci of 5, 0 and negative 5, 0. We could do the same and get our slope intercept form, right? So if we come up here and we look, we notice that we can solve for the x-intercept. We've went over these before, so I just kind of skip plugging in 0. So we know y is 0 when we're solving for x, and we know x is 0 when we solve for y. So now I got x squared is equal to 16 square root both sides. So now I got x is equal to plus or minus 4. Multiply both sides by 9. Y squared, square root both sides. So y is equal to 3 plus or minus 3. So I know my order pairs, right? We got this, and we got this. We got this, and we got this. Okay, we're good. So knowing that, I can solve for my my slopes. I'm going to pick one of the order pair. I got from order pair 2, I got the negative 3. From order pair 1, I got 3. Oh, my apologies, guys. We're going to pick one of these. And if you notice, they're all about the origin. So 0, 0. So we're going to pick that order pair. The same with the example above was centered about the origin. So that's one of the order pairs you want to use, and then one of their axes. I apologize. I should have caught that. So now I got 0 minus that 4, so 3/4. So now I can write my y equals 3/4 x. So I'm going to pick C based upon what my findings are. Okay. Okay, moving on. We're going to find the equation of the hyperbola from the given. So we have this graph here. It's blowed up a little bit better so you can read it. Makes it a lot better. We notice that we have y equals b over a. This is from algebra, which is y equals negative b over a. So this is going to give me my slope-intercept form, right? We know that x squared over a squared, because it's focused at the origin, which is 0, 0 right here. So h is 0 and k is 0. So we know we have this to work with. In this case here, let's look. You can see that 6, you see 6 right here, negative 6. So I know that a in this case here is 6, right? Let's determine, we know the center, and I should have done that in the other two above, so I apologize for not writing the center down. So when we look at it, 6 here, right? And then we have 3 here. So I could say a comma b, which is 6 comma 3. I can use this and this to find the slope. Okay, so I've got the slope. Now let's take b over a and set it equal to m. We know, let's plug in and solve for b. You could do this to double check if you want. We know that a is 6. Slope is a half. Multiply 6 to both sides. Then b equals 3. Check, we did great. We could do the same for a, check for, if you wanted to check to make sure you're right. But now that we've done all this, we know we did good. We got x squared over a. A is 6, and we need to square it, plus y, or minus y, plus y, over 3 squared is equal to 1. So x squared over 36 plus y squared over 9. Need to check, because sometimes that will be a negative there. There's a time, and if you go back to your formulas, you'll notice that it did have one where it was x squared over a plus the y squared over b. And then we did have one where it was a minus. So it will be good to double check and make sure if it is minus. And in this case here, it is minus based upon the graph. So just double check, make sure that that's what we're working with. And so I'm going to edit this right quick. So this is my formula, my equation. Okay, so moving on. It says rewrite the following equation in one of the standard forms of the conic sections and identities. So let's solve it and rewrite it. Well, first thing we need to do is get all the y values together and x values together and get it in a format to where the coefficients on them are positive 1. So I'm going to come over here and do it like this and give me some space for this new term. Okay, now I need to divide by 2 because I need x and y squares to have a positive 1 coefficient. Now that I've done that, I have x squared minus 8x blank plus y squared minus 6y blank is equal to negative 49/2. And I'm going to leave it written like that for now. Now I'm going to take b over 2 and square it to find what's going to make my perfect square. So I got plus 16, and what I do here, I'm going to do over here on the other side of the equal sign. B over 2 squared is negative 6 over 2 squared is negative 3 squared, which is 9. All right, so now let's do this. I got negative 49 over 2 plus the 16 plus 9. So I clean that equal side up here. It's a half. I'm going to write imperfect. Well, I'm going to write it in perfect squares, yes. So I know that I got x. And before you square it, and this part would be what would go here. That's a good helpful hint. Same. Okay, and that means now I can write it in a perfect square. And that is my answer. I'm just going to highlight it. It didn't change. Okay. All right. Now, our next one, let's talk about this application problem. So on this application problem, it says that we have an asteroid that travels an elliptical pathway with a center of a planet at one focus. If the minimum distance from the asteroid to the center of the planet is 342,300 kilometers and the maximum distance is 404,900 kilometers, then what is the eccentricity of the orbit? All right. So first, let me draw this out right quick. Let me get my drawing going. I'm going to use this, make me a straight line. But it's a little good. Let's go back to our drawing. And let's plot. Let's put our center. Let's put our center. Let's put our planet where it was talking about. Now, it said we have a maximum distance, right? So we have a max 404,900 kilometers. And this is my vertex, right? And asteroid, we can name it right here. And then we have a minimum over here. My vertex. All right. So remember, the eccentricity of the ellipse is found by the ratio, right? Ratio of E is equal to C over A. All right. Now, whereas the distance from the center of the ellipse to the vertex and, excuse me, let me write it down. I think that might be easier. A is going to be the distance from the, oops, my writing got a little carried away. Well, maybe it'll, there we go. My apologies, guys. Distance from the center of the ellipse to the vertex. Okay. Now C is going to be the distance from the center to a focus. Okay. So now that we've done that, we notice that the center of the planet is one focus of the elliptical orbit. So we're going to consider it as just a point. So we notice the length of the majority or the major axis can be determined by adding the maximum and the minimum distance that the asteroid is from the center. So again, we're going to say the length of the major axis is the sum of and that's going to give me the major axis. So let's add it up. So that's going to give me a total of 747,200 kilometers. Okay, let me scroll down. Give me some room here. So far, so good. All right, so now the length is as the same as 2a. Okay, so the value of that's found is by dividing by. So this length here is going to be like saying 2a, right? And we're going to set that equal to the length of the major axis. Okay, and then when we did, and I'm going to abbreviate length, major axis. Let's do it like that. I'm going to divide by 2. Now I got A is equal to 747,200 divided by 2. Let's divide that by 2. Now I get 3,736,000 for my A. And now that I know that, next I'm going to figure out my C. Well, the value of A here is also represents the center of the ellipse. To determine the value of C, we're going to subtract the center of the ellipse, which is my A, minus the distance of the focus to the vertex. Okay, so we're going to take what we got for A here, 373600, and I want to subtract that from, let's come back up here, from this. Okay, so 342,300, or minus, I keep saying from. So now I get 31,300 for C. All right, now that I've done that, I can solve for the eccentricity, right? So I'm going to say, okay, E is equal to, and it's C over A, which is 31,300 or 31,300 divided by 373,600. And round to the nearest thousandths. So that's going to be approximately. That's my eccentricity.